Hello and welcome to Teach Up, where we show you how to do well on the AP Calculus test and how to be fast. Today we want to do the following problem. A garden in the form of a rectangle is fenced on three sides. The gardener decides to leave the fourth side open. If the total fencing available is 250 feet, what dimensions will maximize the area of the garden? So to get started, I like to just have a small diagram just to help me visualize what we're working with. So here we have this area. On one side we have W, we have the length, we have another W, and then the fourth side is open, and we want to fence it with 250 feet. So that means we have here 2W plus L is going to equal to 250. And what we want to do with this problem is we want to maximize the area of the garden. Now we know that the area of a rectangle is given by the formula length times width. And here, because we have two variables, we're going to want to rewrite this where we only have the function represented with only a single variable. And we can do that by just using this information. We're going to solve for one of the variables. Let's go ahead and solve for L. L is equal to 250 minus 2W. So substituting that expression into the area formula, that's going to give us 250 minus 2W times W. That means that the area as a function of the width is going to be 250W minus 2W squared. Now, since we want to maximize the area, what we're going to need to do is we're going to have to find the first derivative, set it equal to 0, and see what value of W we're going to get. So we're going to get here A prime of W then is going to equal to 250 minus 4W. We're going to set this equal to 0, and then we're going to solve for W. You have 250 is equal to 4W, which means W is equal to 250 over 4. Well, if you divide 250 by 2, you get 125, and divide by another 2, you get 62.5. All right, and just to make sure that this is indeed a relative, this is going to give us the relative maximum, not the relative minimum. We can just use the second derivative test real quick. By taking the second derivative of the area function, we would get -4, which is always going to be negative. So that means conceptually that even at the point 62.5, the second derivative is still negative. That tells us then that we're going to have a relative maximum there. So our relative maximum indeed will be when W is equal to 62.5. And when W is equal to 62.5, what should the length be? Well, the length is 250 minus 2 times the value of W, which we're going to substitute here, 62.5. So L is equal to 250 minus 125, or L is equal to 125. So the dimensions that will maximize this area then will be a width of 62.5 feet and a length of 62.5, a length of 125 feet, which means that our answer then is A.